Yeah, thank you, Claudia, for this very kind introduction. I'm very happy to be here today and to give you this presentation. And I will today talk about the consequences of flexible power plant operation, which we were facing here in Germany, and about our experiences from the laboratory, which we have here in Essen, and where we investigated more than 400 failures per year. And I would like to give you some insights about what we did in the last few years. But let me first of all talk about the past. In Germany, the coal-fired plants were in the past operated more or less at full load all of the year. So we had about 7,000 operational hours per year, and therefore cycling and flexible operation was not that much an issue here for us. We more or less shut the plant down for maintenance purposes once a year, performed all the maintenance jobs which were to be done, and afterwards we went back to operation again. So based on that, the failure mechanism which were relevant to us was more or less creep only. Yeah? So cyclic exposure was not there that much, and therefore we did not face these type of damages to the plant, and saw more or less only creep damage for long-term operational issues. Also other things, but as I said, cyclic operation was not that much an issue. So the number of starts compared to the full load hours was quite low, yeah. And as help, the VGB offered guidelines which are available to the industry, giving some information about operation, or how to optimize operation, how to optimize inspection, depending on the creep. We have this standard 517, where we give you a good practice of how to deal with different microstructural findings, and therefore quite good knowledge was there. Yeah, and over the years, as you can see on these slides, which I want to show you now, you can see here quite well that in the last years something changed in Germany. Yeah, you see here on the x-axis you see the years, and on this axis you see the operational hours which we have per year, and on this axis you see the number of starts. And here on this slide I would like to compare 3 different plants which are quite representative for different regions of Germany. First of all, you see here the plant A, which is located in the north of Germany, close to the North Sea, where we have in Germany lots of the wind turbines being installed in the north of Germany. So therefore, you have quite a lot of wind production there, directly localized in this region. Yeah, and if you look at this graph, you'll see that within the last decade, the number of operational hours significantly decreased. Yeah, so that's clearly here to see, decreased to operational hours in the range of 1,000 hours in the last year, 2019, and so you see a massive drop of operational hours. At the same time, you see here for this specific unit, you see also a drop of number of starts. Which indicates that the lifetime consumption at this specific plant in total, yeah, even if it's much more flexibly operated, the total amount of lifetime consumption is less than it was before, even if it's more flexibly operated. And comparing that to another plant in the middle of Germany, where the situation is not that severe, you see also here a significant drop of or significant decrease of the number of operational hours, but at the same time you see that the number of starts is it's constant. It's slightly increasing. Also for this plant, if you look at the total number of lifetime consumption of the amount of lifetime consumption per year, you will come to the result that also these plants, even if they are cycling much more and they have to be much more flexible, the total lifetime consumption per year will be less, or at least not more than it was in the past. Yeah, and looking at another plant here in the south of Germany, there the story looks a little bit different. As I mentioned before, the most of the generation for the renewables is located in the northern part of Germany. So you have to transport power to the southern part of Germany, and therefore the production for the conventional industry in the south is a little bit different, and that's what you can see on this slide. First of all, also here, then the number of operating hours is decreasing, but not that much decreasing as it is decreasing for the other two locations. And at the same time, you see a massive or quite massive increase in the number of starts. So also here, they are working much more flexible and operating much more flexible. Here you will see that that there's a shift between the mechanisms which will lead to damage, which as the operating hours more influence the creep issue, the cycling operation more influence the cyclic damage which can appear. So here we will see a shift to a different type of exposure, and therefore we have to check the plants and to modify some things, especially for this type of plants. But also, and that's what is somehow the consequence of it, you have to be very plant dependent what you do and what the exposure will be. So it can really differ from plant to plant, and therefore it has to be evaluated for each and every plant, and we cannot have a very general approach due to this specific situation, which is very plant specific all over Germany, so to speak. Yeah, so there are many plants, as I mentioned before, which do not face a massive increase in in lifetime consumption per year, and therefore we expect these plants also to work flexibly and to reach their end of life, which is as per political decisions made for 2035. So without any specific damages on flexibility reasons. Yeah, but there are other plants which will face and see that. Beside that, we have always this issue that the plants are not operated full load for many hours, and they are not operated for many hours. So we have preservation issues, and we have to work out preservation concepts where we have to be able to be very rapidly back in operation again, and therefore it's quite important to study this and to find good preservation concepts in order to be back to operation quite fast. And looking at the cycling issue, we have to use different lifetime monitoring tools, and we have to also identify and to use different inspection methods compared to what we did in the past. Yeah, and looking on this water chemistry issue, which is also quite complicated, we have to shift very fast from the classical AVT mode to the oxygenated treatment back again. So I mentioned to you that we do not expect many failures or not that many failures in all the plants, but there will be some specific plants and some specific problems which we are facing. And I would like to refer to one big damage which we were facing in several years ago. And you see that this was quite a massive damage. That's what you can see on this slide. That's parts of the boiler house, which you see here. That's part of the mainstream line, which you can see here. So you see that the wall thickness is quite thick. Here we are looking into the machine house where the turbine was located or is located, but here you see that there was also here a massive damage. Yeah, and here you see some parts of the recirculation pump, which actually faced or made the problem. Basically, we had a big damage, so this topping of this recirculation pump cracked, after approximately 170 operational hours, and the plant had about 1,400 starts and stops. And what is quite interesting actually is that this pump casing was inspected only 2 years before this failure appeared by means of ultrasonic testing, but it was, as I write here on my slide, it was a conventional ultrasonic testing. And so we were not able to find this cracking in the initial stage. And yeah, first of all, as you probably can imagine, if you're facing such a big damage, we performed a very detailed root cause analysis, and I would like to show you only some minor results out of that and give you some ideas of what we can do and what cycling operation can cause, and what consequences it can have to our daily operation and to our daily maintenance jobs. So basically here you see this boiler circulation pump as a picture, as it should look like in a good condition, in new condition. And here you see the drawing. And if you look at the drawing, you will directly see that this design is not that good for let me say, not that good for cycling operation. If you look at especially this direction, you see here this notch, which is located here. And as a consequence of this notch, you'll have quite a high stress concentration at this location. And yeah, this pump worked very well for 20 years of this normal operation, but afterwards a crack appeared here in this location, and was initiated at this location. And this was not the only pump which suffered from that problem. We in the follow-up, many other pumps of different plants were also investigated, showing the same problems again. So let me now show you the root cause analysis, or some pictures from the root cause analysis. If you look at this picture here again, you see a segment out of this notch here, and you can directly see that there are lots of secondary cracks, and that these cracks are all initiated here at this notch. Yeah, and from macroscopic point of view, if you look here, this is a fracture surface. If you see that, that is this area here. Here's the crack, or the end of the crack. Here is marked on this slide. So you see in this region we had some wall thickness left, but it was nearly cracked or nearly broken at this pump here, which we investigated. And looking at this fracture surface, you can directly see that we have lots of lines of crack arrest, which really indicate that the rupture is stepwise, cyclic and stepwise process. Yeah, also looking at the surface a little bit more in detail, we will see that we have different crack propagations, and that we have the distance between these lines of crack arrest are different. That shows you that different starts and different stops led to a different crack propagation, and for sure, the thinner the wall was, the more the crack propagated by start or stop, and therefore we could really identify or could really see the crack propagation as per circle, yeah, as per individual circle, which was very interesting and which helped us to identify what will lead to this specific damage and what is responsible for the higher crack propagation. Yeah, let me now come to another thing, which is the flexible operation and finally the outcome on the water chemistry. As you know, we have had a big new build initiative in the last years in Europe. So we installed many new plants and stopped operation also for older plants in order to have higher efficiency, in order to be more environmental friendly. And therefore we have very new plants operating, but these plants are operating with steam parameters and with working parameters where you have to use the so-called OT mode. OT mode means oxygenated treatment. So the water chemistry, or the water, the feed water, has to be oxygenized in order to avoid flow accelerated corrosion of these plants. And yeah, the idea is to form a hematite layer which protects material from this flow accelerated corrosion. But at the end of the day, if you use this oxygenated treatment, you will never start and never stop the boiler with the oxygenated treatment, because if you do so, you will have the problem that you have quite high oxygenated water inside your boiler during the period of non-operation, and that would lead to oxidizing and to attacking the material. And finally, you would face, or you could face, a failure which I showed you before, where you form this small oxidizing attack, resulting further on in this kind of damage which I showed you. So basically, you have to switch always into AVT mode before stopping the boiler, and to start with AVT mode, therefore, before going back to regular operation. If now your start and now your operational periods is quite short due to the flexible operation, it will be very complicated to do that and to follow that procedure, and therefore the your monitoring is quite different to what it was in the past. So it's very important to only have or to really reach also this oxygenated treatment somehow, in order to not get these individual problems which I described to you before. But at the end of the day, very short period make this very complicated, and so it's quite difficult to operate these boilers in only very short periods with this mode. Yeah, let me now sum my talk up. First of all, about this damage event which I wanted to show you, or which I showed you. I wanted to show you that this was a very specific damage event which we had here, which really faced, or which really resulted in a very big damage in the plant. And so cyclic can lead to really massive damages in the plant, and it's very difficult to really find them. You have to optimize your strategies of maintenance and also of inspection on that. And yeah, this specific damage I showed you, that so-called strain-induced corrosion cracking, this is quite hard to find with this conventional ultrasonic methods. Therefore, we introduced here this phased array ultrasonic testing, and learned how to find this. By the way, one major finding is that you should keep an eye on the design of your components, especially if your plants are designed for baseload operation, as ours was. It is absolutely necessary to check and to look at which positions do I have designs which could result in an early failure, and which could result therefore in a massive damage. And yeah, and then you have to, or can try to optimize the design for this specific cyclic and flexible operation in order to avoid this damage. Yeah, in this case of the pump, we also introduced the preheating of this pump as a result, and as one way to reduce risk of cracking. And this was also very successful, and is a good way of reducing the stresses which could be created. Yeah, for the operational maintenance, we believe that we have to find plant-dependent solutions. As I showed you before, each and every plant is different, or can be different. If the cyclic exposure is different and then you have to check how relevant is it for me, and what kind of testing do I have to perform in order to find early damage, and perhaps specific testing methods have to be applied in order to find the cracks which you're searching for. And at the end of the day, and that's the last point I would like to refer to, is that sometimes you have to change the operational parameter. That could be water chemistry, that could be also warming up some specific components. And a last and important point for me is always the preservation of the plant in periods when your plant is not operated. Also in this period, you have to keep an eye to not lose lifetime and to keep your plant fit for purpose. Yeah, I'm now at the end of my talk. My contact data, you'll find them on this slide. I'm happy if you have questions, and maybe we have some time for some questions now, and if not, also no problem, please contact me, and I'm happy to be at your disposal at any time. Thank you very much.